and Michael? Well, yeah, but the technical definition is breaking numbers down and putting them back together. Okay? Breaking numbers down and putting them back together. All right, there's a lot of examples here. This is not difficult, okay? But sometimes you make boo-boos. All right, so we'll start off really easy. Okay? If we have 4 parentheses n plus 5. Okay, what does it mean when you have a number next to parentheses? What operation? Emma. Okay, we are going to multiply. Okay, here's how I like to think of this. The items in the parentheses, think of as your neighborhood. Just go with me on this. It's your neighborhood, right? You have houses around you, yes? Okay, some of you have fundraisers for your sports teams or your, right, your band, your competition, your gymnastics, your cheerleading, whatever, yes? Okay, so if you are going to distribute a flyer, right, or you are going out and you're selling something, yes? Right? We all know about this. Okay, do you normally or do you want to go to each house in the neighborhood to try to sell it? We would hope. Okay, so you are distributing throughout your neighborhood, yes? Which, i.e., you're going to all of the houses in your neighborhood. Okay, here's how I like to think of it. The number on the outside is you. That's you. Okay, and inside, these are all the houses in the neighborhood. Okay, you have to go to each house. This is where you're going to make your boo-boos. Meaning, let me rewrite this. Ah! What happened? Don't know. I get scared. Okay, so the distributive property simply means you have to go to each house. What does 4 times n look like? Just yell it out. 4n. This is the next step. And again, as I told you throughout the year, I'll always tell you guys where the children through the years have made their boo-boos. Now don't write this down, but this is what they do next. Did you go to all the houses in the neighborhood? No, you didn't. That's the most common mistake right there. You don't just bring down the next number. You don't just bring down the next number. You have to distribute yourself, or you have to go to the next house in the neighborhood. 4 times 5 is 20. That then is distributed. 4n plus 20. That would be your answer on your quiz. You don't know what the value of n is. Okay, so that's all the farther that you can go. You just distributed the 4 with the n and the 5. Does that make sense? Everybody good there? Are you sure? Question. Okay, how did we get to 20? Very good question. We had to multiply, right? This is you, remember? This is you. And you went to the first house here, which is n. You went to the second house, which is 5, and it still's multiplication because you have a number next to parentheses, right? You have to multiply inside the parentheses each number. Good question. Everybody good? Oh. All right, next one. Okay. I don't know why we're clicking over there. Okay, next one. What's different between this one than the first one? There's only one difference. Tyler. Absolutely. It's subtract. Does everything stay the same? Yes. You take the first number, which is u on the outside. You go to the first house and you multiply. We get 12y. You bring down whatever operation is there. Okay, add or subtract. That's really all it's going to be. It's not going to be well, it could be multiplication, but it's not. Add or subtract. Okay, and now here's the common mistake. We have to go to the next house. 12 times 3 is 36. And we now have problem solved. We just distributed the 12 to y minus 3. So far, so good. Anybody remember how this works? We start off easy, and then it gets harder. Yeah, I know. You can do this. It's going to get harder here. Yeah, I know. All right, so far, so good, though, right? Okay. Okay, next one. All right. 2 parentheses n plus 5 plus 12. What's different? There's another house in the neighborhood. Okay, can you have as many houses as you want in the neighborhood? Yes, it doesn't matter. The process stays the same. Now, instead of going to 2 houses, you got to go to all 3. Okay, so here we go. 2 times n is 2n. Bring down the sign. Go to the next house. 2 times 5 is 10. Bring down the sign. Whatever's there, that could be a subtraction sign. Okay, they don't all have to have the same sign. Okay, whatever sign is there, you just bring down. Okay, now we got to go to the next house. 2 times 12. Okay, now, are we finished? Ooh, we are not finished. This would be an incorrect answer. Why? Come on, why? Go ahead, Emma. Okay, how do we solve it? Go ahead, honey. Okay, Emma says we got to add 2n plus 10 plus 24. Yes? Any takers? Uh-oh. I'll assume you're silenced or you're not sure. What do you think? Yes? No? Tyler, what do you think? You say no? Why not? Why? Why not? Because why? All right, very good. Okay, look here. You can you know what we call these right here? Fancy math term. We call these no. There's no variable after it. They're not coefficients. The 2 is a coefficient, but not the 10 and the 24. They are called constants, but they are also called something like terms, meaning they're the same, i.e., they're constants. They're both constants, right? Which means, do we have to add them together or can we just let them go? We have to add them. You have to. Okay, so your answer here is 2n plus 34. That is your answer. Okay, again, we are always going to ask you to simplify. Okay, what is in the red We turn it into green. That's the simplification part. You're always looking to simplify things in the world of mathematics. So far, so good. Kellen, I hope you're paying attention. Everybody good? Everybody good? Does that make sense? Like terms is going to be said a lot in here. You always want to look for things that are the same and combine them or subtract them or multiply them or divide them. Doesn't matter. My recommendation to you is once you think that you are done, take another look to see if you can simplify. Because I will be honest with you, that's where most of the people lose their points. Okay, it's the simplification part. It's not the part that you don't know what to do. It's then simplifying it to make it as easy as possible. All right, so good? All right, next one. All right. Ooh, doggy. Oh, what is different with this one than the other one? Be careful. Be careful. They get harder. Awesome. Very good, sir. There are two numbers on the outside of parentheses. Question number one. Do we add them together? Oh, I heard a lot of no's. Why not? Michael? Okay, I'm assuming you mean the 8. Yes, he is absolutely correct. Do not add the 5 and the 8. They do not go together. Not yet. Okay, listen carefully. Anytime that you have a number next to parentheses, you have to distribute first. That 5 is like another house in another neighborhood. We'll tack it on at the end. That make sense? Okay. So we got to do this. So we got to do this. 8 times 3 is 24. Plus, we bring down our operation. 8 times x is 8x. And now we can bring the other house from the other neighborhood. Does that make sense? What do we call the 5 and the 24 here? We just said it last screen. Max? What do we call them? Terms? Okay, what kind of terms? You're right. Kehan. Yeah, they're like terms. That's the math term. That's the math terminology that you're going to hear. They're like terms, meaning they're both constants, right? Instead of saying both constants, we say they're like terms. And people in the math world understand that we need to add those together, right? So we should get here our final answer. How about that? Is 29 plus 8x. And that's all the farther that we can go. We can't do anything else. So far, so good. You sure? Okay. What if we have this? Oops. Uh-oh. 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 N parentheses n plus 1 parentheses 9. What's different about this? Max. Okay. The parentheses are in a different place. Michael? The number's on the outside? Okay. Okay. So the number, you, right, as we refer to, you are in, we'll say now you're in the back of the neighborhood. Does that matter? No. It's like you living in the back of the neighborhood. It doesn't matter. Okay? So you distribute the same way. It doesn't matter where you're at. Bring down the operational symbol, and we get 9n plus 9. And that's all that you can do with that. That's your answer. It doesn't matter whether it's in the front or behind. You do the same thing. You distribute throughout the neighborhood. So far, so good. Okay. What are the two things that are going to get you? We'll go back to the original one. Bless you. What are the two things that are going to get you? You're going to do this. What's the next mistake you're going to make? Yeah, you're just going to bring down the 5. That's a no-no. Don't do that. You got to multiply each house in the neighborhood. Okay, what's the next one? That's the most common mistake. The next one is you're going to forget to combine like terms. That is correct. My suggestion to you is when you think you are done, take another look at it to see if you have like terms. Okay? So far, so good. All right, question. Are you ready? Okay. What if we have something that looks like this? Might want to write this one down. What if they give you a picture? X plus 3 is the width, and 4 is the length. And now they're going to ask you to use the distributive property to write and simplify the expression for the area of a rectangle. Holy cow. First question is, you got to know what the formula is for the area of a rectangle. Right? If you don't know, where can you look? Oh, who remembers from day one? Okay, hon. Your formula cheat sheet under the resources in your class notes, right? Under class resources, I should say, right? Your cheat sheet is there. Okay, do we know what the formula is for the area of a rectangle? Nobody knows. Uh-oh. Emma knows. Emma. Area is equal to length times width. That is correct. So how do we write this? Sorry. I made a boo-boo. Length times width. Right. Okay, are we done yet? No, because it said we needed to distribute to find the area. So we do one of those. Bring down the sign. Make sure that you multiply the second house or the third house. That is your answer to finding the distributive property of the area of that figure. Does that make sense? Okay. Any questions about the distributive property? Breaking numbers down into smaller parts and putting them back together. Okay, let me show you one more. What if you may have to do this actually. What if you have this simple multiplication problem? 6 times 23. Okay, in elementary school, you probably did this, yes? And that's fine. That's if you just wanted the answer. But what does 6 times 23 look like if we were to use the distributive property? Okay, this is what we mean by breaking numbers apart and putting them back together. Can we break apart the 6? No, it's a single digit, right? You don't ever want to break apart a single digit. That doesn't even make any sense. Okay, is it fair to say that 23 can look like 20 plus 3? Okay, this is the breaking apart. Right, so we would say 6 times 20 plus 6 times 3. Does that make sense? Okay, this is the breaking apart issue, right? We broke apart 23, right? So here we get 120, yes? Plus, here's the put together part, 18. We broke numbers apart and now we're putting them back together. Put together was probably the first term you learned is adding, right? Put together. Right? And now we arrive at our final answer of 138. We broke the numbers apart. We put them back together. Does that make sense? Okay. All right. That's it for the distributive property